Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and a very good day to all. Okay, my name is Ahmad Alif Imran bin Ahmad Iswari. I am a final year student for Bachelor Engineering Technology in Rail Transportation with honors. So my final year project is the study on application of solar panel technology in power distribution for the automatic platform gate system in MRT2. Yeah, I am supervised by TS Dr. Zuraidah binti Ngadiron. The poster will be covered the abstract, which is then the chapter 1 introduction, the chapter 2 or chapter 3 the methodology, and then the result discussion and the conclusion. So without wasting time, let me start review my poster. Okay, we will start with the abstract first. So the abstract is the global photovoltaic of PV generation system has grown very quickly in the recent decade since the installation cost has decreased significantly as the technology advanced. So our Malaysian government has encouraged the use of renewable energy, particularly the photovoltaic system, to replace the fossil fuels that is currently in use to reduce the greenhouse emission and the reliance on currently limited fossil resource. So by cooperating the PV system in the underutilized region surrounding railway station, rail transportation can become more sustainable and environmentally friendly. Due to increasing circumstance, so this current trends will imply that the railway energy consumption will continue to rise as more railway being made. So the aim of this study is focuses on the potential of implementation PV system at Klang Valley, mass rapid transit to station for the application of automatic platform gate system. So the preliminary studies at MRT2 station consist of existing power supply system to the automatic platform gate system and existing backup supply, the power consumption of LPG system, and the approximate PV sizing for the system. This study would use the calculation method using several equations and making the simulation for the development of the PV system. The parameter involved in this study would be the current and voltage, which is used by the LPG system, the power and energy supplied to the LPG system needed to develop a sufficient PV panel. So then the result of the study will show using the PV system would be much more energy and cost efficient for the longer time frame compared to the conventional power supply. So the study will prove that the usage of PV panel in railway application can be done. Yeah, next is introduction. So the objective of this study involves the investigate the parameter of photovoltaic system for the application of APG system at KVMRT for elevated station. Next is to develop a simulation model for the power distribution of photovoltaic generation system for the APG. Then the third objective is to analyze the performance of APG system between the PV generation and the conventional supply system in terms of cost, energy efficiency, and as a power supply. So the scope of the research is consisting the APG used for the KVMRT2. So the PV sizing will be acquired by calculating the area of station roof in order to estimate the maximum size PV to be installed. Other than that, the type of solar PV module will also be considered, and the position of PV module is placed at installed at the roof of the station. Okay, for the methodology, we will calculate we need to do some calculation that needed to be made so that we can get the PV sizing. So the two main formula that use are P equal to IV and E equal to PT. So this is the formula for power which is used to identify the total power used by the electrical appliance, and then E equal to PT, so which is we will give the watt hour, so calculating the load used by the electrical appliance. So this calculate formula will needed to calculate the load of the electrical appliance for the day and for the night. This is because for at morning there will be sun, and however when at night there will be no sun and zero insolation. So when at night, because of zero insolation, it will need to solely depend on battery, which will need different calculation compared to the during the day, which is there will be battery and solar to supply the power for the APG system. Then the current IL is the formula to determine the average load current for the electrical appliance for the entire day. So the information for voltage and the current have been acquired from on-site at the MRT station. So the LPG system generally use 110 voltage DC, volt DC, and on average 2.2 ampere current. Next is the watt hour load equal to watt hour night divided by percentage of battery. So this is the watt hour at night formula is used to calculate the battery using sizing needed for the electrical appliance so that it can be operated at night where there are no insulation present. So this calculation have taken in consideration of the percentage of battery efficiency. So generally the battery efficiency is around 0.7 or 70%. Okay, then move on. We go to the watt hour load equal to watt hour night over percentage of battery efficiency plus watt hour day plus watt hour night over percentage of battery times number of autonomous days. So this formula almost the same formula as above. In addition, the calculation for the autonomous operation. So this calculation takes in if the battery were needed to supply the electricity for at least a few more days. That's why it have the watt hour day plus watt hour night divided by percentage of battery times the NA, which is number of autonomous days. So move on. Ampere hour battery. So the ampere hour battery is the continuing calculation to calculate the load for the battery supply. This calculation was made to calculate the ampere hour battery needed so that it can supply the sufficient energy for the electrical appliance. Then we can see the next formula is watt hour PV. The watt hour PV is a watt hour for the photovoltaic. This formula was used to calculate the watt hour needed for the PV panel to supply so that it can charge the battery. So the watt hour PV have the watt hour day plus the watt hour night divided by percentage of battery efficiency plus the watt hour day plus watt hour night divided by percentage of battery times by number of autonomous be divided by number of recharge. Okay, move on. The next formula is for the array peak watt, which needed to be calculated. Then after we get the peak array, the array peak watt, we can calculate the area of intrinsic, which is the area of PV panel needed to be bought, with the percentage of efficiency for the PV panel. So in commonly the PV panel efficiency is at 0.16% or 16% of efficiency. Then the area of estate needed to be 30% larger than the area of solar panel. So this is to allow the maintenance work and the cleaning work process can be done around the PV panel. Then down here we can see the simulation for the what we call that power distribution of solar and from the conventional power supply. So the solar power supply will become the main power supply. Then the conventional power supply still needed for backup if there is more number of autonomous which made the battery the power in the battery depleted. So when the power in the battery depleted, it will need to switch on the conventional power supply so that it can make sure the train operation does not disturb by the insufficient power supply. Okay, next we will continue to the result and discussion. So the result for the conventional power supply. So this we calculated using the tarif from the TMB. So the operational cost for the conventional power supply is 75 ringgit 79 cents for a month. So the operation for the 25 years is 22,737 ringgit. That is the PV supply. For the first start is 1,500 ringgit for the battery cost, and the PV panel cost is 1,344 ringgit. So the total cost of 1,144 ringgit. The next PV supply is much expensive. So the battery is 9,000 ringgit and the PV panel is 6,476 ringgit and 40 cents. So the total is 15,479 cents. So even the most expensive PV panel is much cheaper than the conventional power supply. So next is the area needed for the PV. So the first type, the PV panel need only 10 meter square, and the area needed to installation is 13 meter square. The next type is will need much bigger space, which is 48.2 meter square, and the area needed for the installation is 62.66 meter square. So the next graph shows the significant difference between the cost and the initial cost for the PV supply. So the next is conclusion. So the automatic platform gate or APG system is one of the main system that we use for the MRT2 station. So adding the solar panel generation supply system into the system, so the significant amount of operational cost can be reduced. Even though it has a much higher initial cost, for the long run, it can cut a significant amount of operation cost needed. That being said, the PV power supply cannot operate without the backup, which is conventional power supply in case of load installation for a long time. So the PV power supply will need to exist with the conventional power supply to ensure the smooth operation of MRT2. This is my reference that I've been used in my projects. I think that's all for me. Thank you.